All right, let's dive into some really cool stuff today. We're looking at open source physics simulations
Yeah,
and all the amazing educational resources that they unlock for people.
that's good.
You know, you listeners have sent in some really fascinating things, and it looks like we're starting our journey in Singapore for this deep dive.
Yeah, and just glancing at the titles here,
Mm-hmm.
we can already tell these simulations are using some really cutting-edge technology to
Yeah,
make physics more accessible.
absolutely. So the first one up on the list that we're going to be looking at today is called, and get ready for this title because it's a long one,
Okay.
Mass and Spring with Accelerometer JavaScript HTML5 Applet Simulation Model by Wolfgang Christian, Open Educational Resources, Open Source Physics at Singapore.
Wow.
That's a mouthful.
It is a mouthful,
You know.
but it's packed with information.
It is, it is.
So from that title, we can already see that we're dealing with a simulation of a classic physics concept, a mass and spring system
Right.
designed for educational purposes.
Mm.
And it uses a combination of HTML5, JavaScript, and even accelerometer data.
Oh, hold on. Accelerometer.
Sure.
You mean like the things in our phones that detect movement? How does that have to do with springs and masses?
That's what is so clever about this. So imagine you're holding your phone,
Okay.
and as you tilt it or move it around,
Yeah.
the accelerometer readings are fed into the simulation.
Huh.
So the virtual mass and spring on your screen will actually respond in real time
Oh,
to your
okay.
movements,
That's incredible.
mimicking the physics of a real spring system.
That's way more interactive than just watching an animation.
It is.
Wow. And you know what? This project actually won the UNESCO King Hamad bin Isa Al Khalifa Prize for the use of ICTs in education.
Impressive.
So I'm guessing that award
Yeah.
recognizes how innovative and impactful this kind of technology is for learning.
Absolutely.
Yeah.
It really highlights the potential of open source education to reach a global audience, especially when it's paired with, clever design choices like incorporating accelerometers.
And speaking of reaching a global audience,
Yeah.
there's a whole section on translations
Right.
in this material that you sent me. I'm curious, how do you even begin to translate complex physics concepts into multiple languages, like accurately?
It's a huge undertaking.
Yeah.
Not only do you need subject matter experts to make sure that the translations are scientifically accurate,
Right.
but you also have to consider all the cultural nuances.
Oh, of course.
Certain analogies or
Yeah.
examples might work well in one language, but completely fall flat in another.
Totally.
Open Source Physics at Singapore likely collaborates with educators and translators from various backgrounds to make sure that the content is both accurate and culturally relevant.
That makes a lot of sense because it's not just about word-for-word translation, right? It's about making sure the concepts are truly understandable across different cultures.
Exactly. And, it's also important to remember that even with all these open source resources available online,
Yeah.
not everyone around the world has equal access to the internet or technology.
That's a really good point. It
Yeah.
kind of highlights the ongoing challenges of bridging the digital divide,
Right.
even as these amazing resources become more and more available.
Yeah, it's definitely something to keep in mind as we celebrate the successes of initiatives like this.
Okay, so we've got this amazing simulation that can run on all sorts of devices,
Right.
thanks to HTML5 and JavaScript.
Uh-huh.
It's being translated into who knows how many languages.
Yeah.
But how easy is it for people to actually use and share this resource?
Well, that's where the embed section comes in. So they've actually provided a snippet of iframe code
Okay.
that anyone can just copy and paste onto a web page.
Wow.
So if you're a teacher putting together an online lesson,
Yeah.
you can embed the simulation directly into your materials.
That's awesome.
Make it interactive for
Yeah,
your
it's
students.
So convenient.
Yeah.
It's like building physics right into the fabric of the internet.
Exactly. And this really speaks to the power of open source collaboration.
Yeah.
By making the code freely available, they're empowering others to build upon their work
Right.
and spread these educational tools far and wide.
It's fascinating to see how something that started with Wolfgang Christian and Lucang Wei, whose names are listed in the credit section,
Yeah.
has grown into this global project. It really shows the potential of the open source movement to make knowledge accessible to everybody.
Absolutely.
And looking at the version section,
Yeah.
it says it's based on Wolfgang Christian's original work hosted on the Computeri website, which is a digital library for physics and astronomy education.
Yes.
So it's like a chain reaction of knowledge sharing,
Exactly.
with each contribution sparking new innovations and reaching even more learners.
And that brings us to this incredibly long list of other resources at the bottom of the page,
Right.
which seems like a treasure trove of links to other simulations.
It does.
Workshops and even awards related to the open source physics at Singapore project.
Wow, that list is extensive.
It is.
It's almost overwhelming. Where do we even begin?
It's a testament to the dedication and passion behind this project.
It is.
They haven't just created one simulation.
Right.
They've built this whole ecosystem of resources to support physics education.
Okay, so before we get totally lost in that rabbit hole of resources,
Yeah.
maybe we can just pull out a few that caught our eye,
Yeah.
just to give our listener a taste of what's out there.
Okay.
Okay.
That sounds like a plan. Let's see. Here's one that immediately jumps out at me.
Okay.
It's called Antibiotic Resistance Dice Simulation.
Okay.
Now, you might be thinking, what does that have to do with physics?
Yeah, I was just about to ask that. It
Uh-huh.
doesn't exactly sound like something you'd find on a physics resource website.
Exactly, and that's what makes it so intriguing.
Okay.
It shows how physics principles can be applied to understand phenomena
Right.
in seemingly unrelated fields,
Mm-hmm.
like biology. So this simulation uses dice rolls,
Uh-huh.
which are inherently random,
Yeah.
to represent how antibiotic resistance spreads
Oh,
in a population of bacteria.
So by rolling the dice, you're simulating the random chance of bacteria developing resistance.
Precisely.
Okay.
And by adjusting the parameters of the simulation, like the rate of mutation or the effectiveness of the antibiotic,
Mm-hmm.
you can explore how different factors influence the spread of resistance.
Wow.
It's a really powerful tool for visualizing these complex biological processes
Yeah.
in a simplified way.
That's a great example of how physics isn't just about equations and abstract concepts.
Right.
It's a way of thinking about the world that can be applied to all sorts of problems.
Absolutely. And it highlights the interconnectedness
Yeah.
of different scientific disciplines.
Of course.
Physics, biology, chemistry.
Yeah.
They all rely on similar principles,
Yeah.
and they can inform each other in really unexpected ways.
That one really surprised me.
Right.
What else is hiding in this treasure trove of other resources?
Well, how about this one?
Okay.
Rocket JavaScript HTML5 Applet simulation model.
Okay, rockets.
Yeah.
Now we're talking.
This one takes us into the realm of space exploration.
But what can we actually learn from a rocket simulation? It sounds more like a video game than an educational tool.
It might seem like fun and games, but there's some serious physics at play here.
Okay.
Rocket simulations can teach us about concepts like projectile motion,
Right.
gravity, the laws of motion.
Yeah.
They can even delve into more complex topics like aerodynamics
Oh, wow.
and rocket propulsion.
So you could experiment with different rocket designs or launch parameters
Yes.
and see how they affect the rocket's
You
trajectory.
got it.
Okay.
You could even simulate different gravitational fields or atmospheric conditions
Oh, wow.
to see how those factors influence the rocket's flight.
That's incredible.
It's a really hands-on way to learn about the physics behind space exploration.
Okay. I'm starting to see how these simulations can make learning more engaging.
Yeah.
It's not just about passively reading a textbook. It's about actively interacting with the concepts
Right.
and experimenting with different scenarios.
Exactly. And that kind of active learning is what makes these simulations so effective.
Yeah.
They allow learners to visualize these abstract concepts, make connections between different ideas, and test their understanding in a safe and controlled environment.
It's like a virtual physics laboratory where you can experiment without the risk of blowing anything up.
Precisely.
That's great.
And speaking of pushing boundaries, here's a resource that takes us beyond Earth.
All right.
7.3.8.6.3 Earth
Yeah.
and Moon Escape Velocity Field Strength One-Dimension JavaScript HTML5 Applet Simulation Model.
Whoa, that title is a mouthful.
I know, right?
What the world does that even mean?
Don't worry, it's not as complicated as it sounds.
Okay.
This simulation explores the concept of escape velocity, which is the minimum speed an object needs to escape the gravitational pull of a planet or moon.
So it's like figuring out how fast a rocket needs to go to break free from Earth's gravity and travel to the moon.
You got it.
Okay.
And this simulation likely shows how the gravitational field strength between the Earth and the moon changes as you move further away.
Right.
It might even let you experiment with different masses and velocities
Interesting.
to see how they affect the object's trajectory.
Okay, that makes more sense. But how can something as abstract as escape velocity be explained through a simulation? Wouldn't it just be a bunch of numbers and equations?
That's where the power of visualization comes in.
Okay.
So imagine you launch a virtual ball upwards.
Okay.
If you don't throw it hard enough, it'll fall back down due to Earth's gravity.
Right.
But if you give it enough speed, that escape velocity,
Uh-huh.
it'll overcome Earth's pull and keep going.
Wow.
The simulation would show this visually,
Okay.
allowing you to see how the ball's trajectory changes as you adjust its initial velocity.
That's a really clever way to make an abstract concept like escape velocity more concrete and understandable.
It is.
It's like taking those complicated equations and turning them into something you can actually see and interact with.
Exactly. And that's what makes simulations such powerful learning tools.
Yeah.
They bridge the gap between theory and reality, making abstract concepts tangible and engaging.
It's fascinating to think that these simulations are available not just to students in classrooms,
Right.
but to anyone with an internet connection.
That's the beauty of open source education.
Yeah,
It democratizes knowledge and makes learning accessible to a
absolutely.
wider audience.
Okay, we've explored some really interesting simulations so far,
We have.
but I'm curious, what else is hidden in this other resources list?
Well, let's see. Here's one that caught my eye.
Okay.
Physics of Cooking Workshop.
Wait, physics and cooking?
Yes.
What's the connection there?
You might be surprised how much physics is actually involved in the culinary arts.
Yeah.
Think about heat transfer,
Yeah.
phase transition,
Okay.
the properties of different ingredients. It's all governed by fundamental principles of physics.
So this workshop probably explores things like how different cooking methods affect the temperature and texture of food.
Exactly.
Wow.
You could delve into the science behind techniques like boiling,
Right?
baking, frying, and even sous vide cooking.
Oh, wow.
It might even explain the physics of why some recipes work better than others.
That's so cool.
Right?
It's like taking something we do every day, like cooking,
Yeah.
and revealing the hidden scientific principles behind it.
And that's one of the most exciting things about physics. It's not just a subject you study in school.
Right.
It's all around us,
It is.
influencing the way the world works,
Yeah.
from the smallest atoms to the largest galaxies.
Okay, we've covered a lot of ground here.
We have.
From simulations of springs and rockets to the physics of antibiotic resistance and cooking.
It's amazing, right?
It's amazing to see the breadth and depth of resources available.
It is.
Through open source physics at Singapore.
It really is an impressive collection.
It is.
And it's a testament to the power of open source collaboration
Yeah.
and the dedication of individuals like Wolfgang Christian and Liu Kang W.E., who are making these resources available to the world.
But before we wrap up,
Yeah.
there's one more section we haven't talked about, the website footer.
Okay.
It seems like a small detail,
Right.
but I think it reveals something important about this project.
You're right. It's often the small details that tell the biggest story, what caught your attention.
Well, for starters, it mentions that there are 229 guests and 1 member online right now.
Okay.
That might seem like a small number,
Yeah.
but it's a reminder that there's a whole community of people out there all around the world who are accessing and using these resources.
It's a snapshot of a global network of learners
Yeah,
connected by this shared passion for physics.
I like that.
Yeah.
And then there's the popular tags section, which lists terms like dynamics, secondary, Android US, mathematics, and superposition.
Right.
It's like a roadmap for navigating this vast website.
It's a way to filter the content
Yeah.
and find resources that are relevant to your specific interest or educational level.
Right.
Whether you're a high school student looking for simulations on Newtonian mechanics or a college professor searching for materials on quantum physics,
Right.
those tags can help you quickly find what you need.
It's like having a personal librarian for physics education.
Exactly.
That's great.
And it speaks to the careful organization and thought that has gone into making these resources accessible and user-friendly. It's not just about dumping a bunch of files online.
Right.
It's about creating this well-structured and curated collection
Yeah.
that's easy to navigate and explore.
Okay, so we've explored the website, we've delved into some fascinating simulations,
Yeah.
and we've even discovered this unexpected connection between physics and cooking. What's the big takeaway here? What makes this project so special?
Well, for me, it's the combination of innovation, accessibility, and collaboration.
Can you elaborate on that?
Sure. Open source physics at Singapore is pushing the boundaries of science education
Right.
by incorporating these cutting-edge technologies like HTML5, JavaScript, and even accelerometer data into their simulations.
Yeah.
They're making these complex physics concepts more interactive and engaging,
Right.
which is crucial for effective learning.
And it's not just about creating cool simulations.
Right.
It's about making those simulations accessible
That's it.
to anyone with an internet connection, regardless of their location or background.
They're breaking down barriers to education and empowering learners around the world to explore the wonders of physics.
Absolutely.
And they're doing it through open source collaboration,
Yeah.
which allows others to build upon their work
Right.
and contribute to this growing body of knowledge.
It's inspiring to see how a project that started in Singapore is now having this global impact.
Yes.
Thanks to the power of the internet and the dedication of individuals who believe in making education accessible to all.
It's a reminder that great ideas can come from anywhere,
Yeah.
and that collaboration can amplify those
Oh,
ideas
that's right.
and spread them far and wide.
But before we get too carried away with the big picture,
Yeah.
I want to bring it back to our listener.
Okay.
What's the one thing you want them to take away from this deep dive?
Well, I think the most important takeaway is that physics isn't just some abstract subject confined to textbooks and classrooms.
Yeah,
It's all around us.
it is.
It influences everything from the way we cook to the way we explore space.
Right.
And thanks to initiatives like open source physics at Singapore,
Yeah.
anyone with a curious mind can dive in and explore these concepts
Right.
in a fun and engaging way.
It really makes you wonder where else these simulations could be applied. I mean, we've seen how they're used in education, but what about other fields?
Yeah.
Could they be used to train professionals,
Yeah.
design new technologies, or even create immersive entertainment experiences?
You're thinking along the right lines.
Yeah.
Imagine architects using simulations to test the structural integrity of their designs.
Oh.
Or urban planners using them to model traffic flow in a city.
That's amazing.
The possibilities are truly endless.
It's so exciting to think that these tools, which were originally designed for educational purposes, could have such a wide-ranging impact.
Yeah.
It speaks to the power of open source innovation and the ripple effect it can create.
Absolutely. And it highlights the importance of making these resources accessible to a wider audience. The more people who have access to these tools, the more creative and innovative applications we're likely to see.
I totally agree. So to wrap up, we've taken a deep dive into the world of open source physics simulations.
Yes, we have.
Exploring everything from simple spring systems to complex rocket launches, and even the physics of antibiotic resistance in cooking.
It's been a fascinating journey.
It has. And for our listener, we hope this deep dive has sparked your curiosity and inspired you to explore the amazing world of physics.
Absolutely.
Remember, those other resources links we mentioned are waiting for you to discover them.
Happy exploring.
Yes!
And until next time,
Until next time,
keep diving deep.
keep diving deep.